So sorry about this for the people online, and I'll hand this over to Darcy Michiel, and I'll let you introduce yourself and take it away. Thank you very much.
Thank you. Hello, everyone. Thank you. Thank you to Doug for inviting me to do this. Do this presentation. This is something that I'm like really interested in. I'm really passionate about, and I talk a lot about with builders and clients. But it's usually before that people bring me the house that their dream house. They already have the plan. They already have the floor plan and stuff. And it's very hard to make those big changes once people have their floor plan. They have that idea in their head. So this has been a good opportunity for me to sort of lay out what I'd want to tell someone before they build their dream house. Yeah. So this is transitioning to all electric homes. So there's a big move on to make electrify houses, and I wanted to do a presentation on how simplifying the floor plan, so making simplifying the floor plan makes it a lot easier to electrify a home. Okay, so my name is Darcy Michiel. I'm a certified Natural Resource Canada energy advisor. So I'm doing this since 2022. I used to work here at UNBC, and I went to a presentation on net zero homes because I've always been really interested in net zero homes. And I listened to a talk about another energy advisor. And he was, afterwards I asked him like, how can I get into something like this? How do I do net zero homes? And he said, I'm looking for energy advisors because the Canada Greener Homes program was just coming out. So there was lots of demand for energy advisors. So I've been really enjoying it. I'm a Canadian Home Builders Association net zero home qualified energy advisor, so I can give a house that designation of a net zero home. There's lots of different designations. There's like greener home, build better homes. There's passive house. There's lots of different designations. So that's one of the designations that I have. And I'm also a certified residential heat loss gain calculator, so that I can size houses for appropriately for furnaces and heat pumps and that kind of thing. So there's a lot of overlap between that and energy advising. There we go. So a little bit of an agenda today. So my introduction, the role of energy evaluators and the role of energy evaluators in the building industry, how efficiency relates to electric homes, and a bit about the BC Step Code, how shape and size influence the efficiency of houses, and then sort of final thoughts. I had some questions lined up, but I don't think they're going to work because I have to like log in or something. So I'm just going to skip those. But I'll just say at the top, this is sort of the first time that I'm doing this presentation, so I'd be really interested in people's feedback on information that they thought was going to be covered but wasn't, or if there's any additional information that you're looking for, or and also anything that you thought was good. Okay, so as an energy evaluator, I have a license to give houses an EnerGuide label. Some people in the room may have had them done. Is anybody done? I do new homes as well as existing homes, and I use modeling software called Hot 2000. So if it's an existing home, I go to the house, I measure all the dimensions, figure out the perimeters, assess what the building construction is. So is it a 2x4 wall? Is it a 2x6 wall? that kind of thing. I put that all into the modeling software, and then it spits out an estimate for how much energy that house will use throughout the over the year, based on the construction of the house and its location. So it's measured in gigajoules, which is not a term that everybody's familiar with, but is not a unit that everybody's familiar with, but it works with houses, because you get a number like 74 or 100 or that kind of thing. And it is, they adjust it. The label is adjusted for where you are. So if you right here, you can see like, this is like a typical house. So this house has a 74, and then a typical house in that same location would be 90. So 74 is a little bit better than what your typical house would be. If this was in Prince George, the 74 and 90 would be where they are. But if the same house was done in Vancouver, right, it would be a 40 and a 52 or something like that. Like it is adjusted for wherever you are. And it gives you a breakdown of like where the energy is consumed, that kind of thing. So like the farther north you go, obviously heating the house is going to be a larger proportion of what the house is using. And then greenhouse gas emissions, it gives you a bit of a measurement on that. So for existing homes, you usually get a upgrade report, a renovation upgrade report. So I'll go in, I'll assess the house, and then I'll say like, you could benefit from putting in triple pane windows or using a heat pump or those kinds of things, or any of those kinds of things. And then you can and you'll get an estimate about how much each of those pieces will improve your energy efficiency. And then you can base your decisions, like your renovation decisions, off of that. So for all electric homes, is going to be a heat pump. You're going to have a heat pump and usually electric resistance heating as your backup. All electric homes will always have a better EnerGuide rating. So like they'll always have a better EnerGuide rating because the efficiency of the electricity is always going to be better. The best you can do with a natural gas furnace is like 98%. And then the worst you can do with electric heating is 100%. So, and then most, like any modern home, electric home now is going to have a heat pump, so it's going to be even more efficient. However, it's more expensive to run because natural gas is so cheap. So natural gas is $13 a gigajoule. BC Hydro, like they've got a bunch of different rates that you can get. I took the flat rate, which is like 12 cents, 12.65 cents or something per kilowatt hour, which comes out to about 35 gigajoules. So for a heat pump to beat natural gas on just a cost basis, it needs to have a COP of 3 or better. So you need to get 3 units of energy out of 1 unit of electricity, so this is an example of a COP for a good heat pump. This is degrees Celsius on the bottom, and then this is COP on the x-axis or the y-axis. And you can see it goes below 3 at like -6 or something like that. So your the heat pump is cheaper to run than a natural gas furnace up until about -4 or -5, that kind of thing. And then so this is my house. Before I switched to a heat pump, so 129 gigajoules, and then after the heat pump. So this is with a heat pump, 87 gigajoules. And that's I also did some other upgrades, mostly triple pane windows, but the heat pump was the vast majority of that. That'd be like probably 30. Yes, performance. So there's a whole bunch of different ways to measure the efficiency of heat pumps. COP is the easiest because it's just whatever unit of electricity that you're putting in, the COP is the equivalent units of electricity or energy that you're getting out. Yes, I can ballpark it.
Oh, yes.
Yeah, I can ballpark it if I had my, and I can look it up after or something like that. But yeah, you can kind of ballpark it. But again, your EnerGuide label is going to be like, it treats all houses the same. So it's assuming that there's 3 people in there, they're having this many showers, which is just not true. Like lots of people, it's not, you know, like you might use a bunch of different things. And I have some detailed my energy use. So at some later slides, so we can talk a bit about more at that point. So are people familiar with the step code? BC step code? Okay. Yeah, that's fine. Yeah. 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 We're talking air source. It's the easiest one. Yeah. 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 For an energy evaluation, I can model all the different ones. So like I can do ground source and that kind of stuff. But yeah, for this presentation, I'm focusing on the easier things to do, which is going to be air source. Okay, step code is part of the BC building code. It's the general, it's the push to make houses more efficient. So step 3 is I believe it was like January 1st, 2025. It's where all houses now are required to be step 3. Step 4 is supposed to be 2027, and then step 5 is 2032. There is right now, and I don't know about 2027, but right now there's also a prescriptive way that you can do it, so that you don't have to, like for a step code, you need an energy evaluator to do the assessments to make sure that it meets step code 3. But you can also do the prescriptive, but the prescriptive is going to be more expensive because then you have to do triple pane windows, and you have to hit all of these metrics, which are going to cost more than just doing using an energy evaluator to do the step code process and do the step code compliance reports.
Step 5 right here.
Yes. Yeah. Yeah.
That's perfectly efficient.
It's pretty close. It's pretty close.
Is that a net zero building?
So when you say net zero, it depends on
does it generate as much energy as it uses?
So no, but so for the step code, there's no requirement to put in solar panels. But for the Canadian Home Builders Association net zero designation, what you do is you can do net zero, which means that it produces as much energy as it consumes, or net zero ready, where it's kind of like, here's the hypothetical plan for a solar system that could produce enough energy to equate it, and then you have to plan for it. So like this is where the roof has enough space to hold enough solar panels to do it, or it's going to be ground mount. It's going to go over there, and it's going to be this big.
At this point in time, every house that's being built has to be inspected and certified for step 3.
Yeah. So my answer is yes. I know south of here, yes. In Prince George, yes, unless you're going to do the prescriptive mode. So if you do prescriptive, then but then it has to be all triple pane windows and the building inspector. But yeah, in Prince George right now, you have to do one of those.
And the builder is responsible to arrange that or contract it to do it. Can they be certified themselves to do it?
Nope. Yeah. So when I get a lot of calls right now from lots of owner builders. So because they go and get they're going to go apply for their building permit, and then the building, so they say, where's your step code compliance? And then they go, what? And I get the call. Okay, so how step code is assessed, it's based on 3 metrics. So it's on the thermal energy demand intensity, which is basically just the building envelope. And then the mechanical energy use intensity, which is how much energy does the house use, not just for heating, but for all things. And then the air change rate per hour, which is what I do as an energy advisor. I do the blower door test. I have a fan and pressurize the house, those things. The units can get a bit confusing. You don't need to be super aware, but a general gist is good. So 1 gigajoule is 277.8, so it's like 278 kilowatt hours. 1 kilowatt hour is 3,412 BTUs an hour. And then 1 gigajoule is like basically a million BTUs an hour. I have to switch between all of those because EnerGuides are in gigajoules. EnerGuides are in gigajoules. The metrics, so the Teddy, MUI, they're all in kilowatt hours per square meter. And then all the equipment, so all the heating equipment is sized in BTUs. Furnaces are usually BTUs, and then heat pumps are in tons. So, and then a ton is 12,000 BTUs. Okay, so thermal energy demand intensity, heating method, it doesn't matter. It's just based on the envelope. So it's how much energy does this building need? So technology can't help you. This is the main stumbling point. So the MUI, the mechanical energy use intensity, and the air change hour, those are things that we can fairly easily improve. This is the stumbling block. So there's 2 ways to meet it. You want to have less than 35 kilowatt hours per square meter per year required to heat or cool the house. So that's not total energy, it's just to heat or cool. Or a 40% reduction in thermal demand compared to the NRCan reference house. Depends entirely on building envelope and the air change per hour rate. So like if you reduce your air change per hour rate, then your Teddy does go down. So ERS reference house, so it's the NRCan reference house. It's a hypothetical house that your house is compared to, where it is code minimum. So they assume code minimum. And then so it's the same size, same floor area, same wall, and then the windows are averaged out around the house. So if you have, so like for a net zero home, windows on the south side are kind of freebies because they let in energy and they'll reduce your EnerGuide rating and help you out. For the reference house, they take all of the windows and they average out around the whole thing, and then so that's what they compare to, and that's what you want to beat by 40% or for the Teddy. Mechanical energy use intensity, so heating method matters, and then in PG, less than 45 kilowatt hours per square meter per year. Total energy consumption, or a 70% reduction in energy demand. This is basically meant by putting any heat pump on there. Any kind of heat pump. So like if you put a heat pump on, it's pretty easy to meet this. And then air changes per hour. So yeah, and then so all of my metrics are to meet step 5. So air changes per hour. Step 5, minimum of 1 air change per hour. We'll improve the Teddy and the MUI. And yeah, so as you make the house tighter, that can cause some problems in your house. Does anybody know what those problems would be? Condensation, yeah. Generally air quality. So yeah, generally air quality. Nope. So the minimum. maximum, I guess. Yeah, so that's wrong. Maximum air change per hour when I do my air test. So when I put the blower door in the, and then you do an air change per hour. The minimum required air change rate for good air quality is like 3 air changes per hour. So you're creating that situation where there's not going to be and this is ERVs and HRVs, so heat recovery ventilation. People familiar with that? Yeah. They're not required by code, but I think they should be. Code is I run into this a lot with builders. Code is just a bath fan. So, and lots of people look at that and go like, oh, a bath fan, that's easy. And that's $200. And an HRV is going to be, installed. It's going to be $5,000 to $10,000. But a continuous bath fan, because you're doing all this work to make the house airtight, and then you're just putting a bath fan in and you're just hitting on, which is defeating the purpose of trying to make your house tight, right? So you want to make your house as airtight as possible, and then put in mechanical ventilation to make sure that all the that you're getting good air quality and that kind of thing. I also am a big proponent of monitoring. So for humidity, that kind of thing, often, especially if you're down south, it's not as big of a problem up here, but it does become a problem. Is dehumidification. So like in my house is not particularly airtight. It's like 3.8 air changes per hour, but we have lots of humidity problems in our basement in the summer. So dehumidifier running a lot. Okay, so some more about the step code. So step 3 is 20% better. Step 3 for part 9. So part 3 is commercial buildings, larger commercial buildings and large apartment buildings. Part 9 is what I have a license to do, like what I focus on. Step 3 is 20% better. Step 4 is 40% better. And then step 5 up to 80% better. And then here's so the requirements for step code will vary with the different climate zones. So Vancouver is less than 3,000 heating degree days. So heating degree days is sort of a measurement of how cold the weather gets. Does everybody know what a heating degree day is? So heating degree day is, they take the average temperature for that day, and then it's the difference between that temperature and 18. So if it's 10 degrees, then that's an 8-degree heating day. And then they add those all up. So so when you do all of that for Prince George, you get 4,900 around there. So we're just below the 6,000 or 5,000. We're just below the 5,000. Yeah. Passive house. So when I say passive house, what do people think of? What are all the? Yep, self glass. What about the walls? Yeah. Like ridiculously thick walls, like R65, R100 in the ceiling. And they also, so step code is somewhat similar in that they use, so a passive house uses that kilowatt hour per square meter. Now that's the part where is it kilowatt or kilowatt hour?
Kilowatt hour per square, because it's an accumulated
consumption. Okay. So, so in Vancouver, for their Teddy, they need to hit 15 kilowatt hours per square meter, which is basically the passive house. So step code 5 house in Vancouver would be, I would consider it equivalent to passive house. It won't actually, like you'd have to go through the whole passive thing to actually get it, but it has to hit this sort of a similar metric. In step code 5 in Vancouver, though, it only needs 1 air change per hour, whereas passive house, you need 0.6 air changes per hour. So zone 5, which is Kelowna, 35 kilowatt hours per square meter and 25 kilowatt hours per square meter for the Teddy. And then Prince George, it's 35 and 45, or the percent better than references. This is the sort of thing with passive house, is that it doesn't change as you go north. So it becomes increasingly difficult to have a passive house, and the farther north you go. So when I do my step code compliance reports, I get this little confirmation as to whether it's going to pass or fail. So this one, so you do for step code compliance, there's a proposed report. So they send me their building plans. I do it all up on Hot 2000, and then I put it through this fancy Excel spreadsheet, and I come up with this report as to whether it hits step code 3 or hits step code 4, and then I usually, this is what you like. This is what you need to do to hit step code 4. This is what you need to do to hit step code 5, and then it'll show you. So this one does hit the kilowatt hour per square meter, but it's not 70% better, and that and then it. For the thermal energy demand, it's the other, so it is 40% better for the Teddy, but it doesn't hit the kilowatt hour metric. Achieving a step 5 house. So step 4 is achievable for most homes. I just make the walls thicker, the windows better, more insulation in the basement. I haven't really experienced a house hasn't come across my desk that I haven't been able just to make the walls thicker and then have it hit the metrics. But shape and size have the biggest impact. Simpler shape and more floors makes step 4 and step 5 a lot easier to hit. Step 5 can be very challenging and impractical for tiny homes. So as houses get smaller, especially ranchers, so like just one floor, it just becomes harder. And something that a lot of people don't think about, or I've had experience with lots of builders, is that they think a step code 5 house needs to be smaller, so they try and make it smaller. When you want more floor area to divide that total cost over, whatever, right? So a 3-floor house is a lot easier than a rancher.
A question.
Yeah.
You say make the walls thicker as if that's an easy thing to do.
Yeah, it's easy for me to do, right? Because I'm just
at the design phase.
At the design phase.
Yeah.
Yeah. I'm just talking at the design phase. Yeah. So it's easy for me to be like, just whatever, exterior insulation, R24, all that kind of stuff.
On that point, then, around town, people having the old original siding taken off and then have the SM put on the outside. That's what the practical doing would be.
Yeah.
Is that correct?
Yeah. But like so if someone is thinking about doing that, I would recommend doing an energy evaluation, because making the walls thicker, or putting, like if you're changing the siding, like I'm always going to recommend, I'm an energy efficiency guy, I'm always going to recommend, yes, you should put in exterior insulation just because you're changing the siding, it's a good opportunity, all of those kinds of things. But the triple pane windows make a bigger difference. So I would always recommend triple pane windows before exterior insulation. And I've done several houses in Prince George where they've put exterior insulation on, but they haven't insulated the basement. So like I'll go down in the basement and I'll be doing my evaluation, and it's all like the concrete's completely bare, which is in your house, that's a hole in the energy bucket. Like, so it doesn't matter how much exterior insulation that you put on it; it's all going to flow out into through the foundation. Okay, so simpler is better. So this is a maniac house. These are both houses built by engineers.
Looks like the
Two
Weasley's
different,
house.
two different types of engineers. But yeah, simpler is better. So this is a passive house in it's in Saskatchewan. If you go on, you can go on Passive House, and it'll they have like little reports on all of the different houses that are built. But this one, I don't even. That's where Passive House is a little bit tricky because I don't even know if this one meets Passive House standard. Like I think this one has 28 kilowatt hours per square meter. So it doesn't hit that 15. And this one has R100 in the attic, R65 in the walls, right? Like triple pane windows, all of that kind of stuff. But it's very challenging in colder climates to hit. So here is my, this is a theoretical rancher, and I have a little, I have my, this is my model here. I was hoping to have two, so like I have a smaller one, but it's not done yet. So we'll just look at this one. But yeah, so this is my demonstration of rancher. So perimeter 271.6 feet, 2,000, 2,100 square feet of space, 9-foot ceilings, volume 1,800 or 1,900 cubic feet. So the surface area of the building, of the envelope, is 6,600 square feet. Surface area to volume ratio is 0.35. And I like this is a little bit crazy, but it's good for it as a demonstration, and it's not that crazy. So like I do see quite a few ranchers. There's a big thing now where not a big thing now, but I've done a couple houses where it's at an angle. So like they'll have the main house, and then they'll have something like this, 2 floors, and a bonus room over the garage, all of those kinds of things. So this is, let's see here. So this is a difficult house to hit step code 5. So step 3, so step 3 is 2.5 air changes per hour. R22, this is all sort of code minimum. R51 in the attic, R20 in the foundation. And this is the design heat loss. EnerGuide rating of 86. And so this is with high efficiency natural gas furnace, so 96% efficient. Annual operating costs $2,007 a year. So Teddy is 76.7. MUI is 86. Long ways away from step 5. So to make it step 4, reduce the air changes per hour to 1.5. Increase the walls to R30. Attic R60. Left the foundation alone. EnerGuide rating, so you see the big drastic reduction in the EnerGuide rating. And then energy consumption for the step 4 is 49. Annual operating costs come down quite a bit. But for step 5, and this just barely made it after across step 5. And then walls, so increase the walls to R43, attic to R80, our foundation to R30, brought the air changes per hour down to 0.6. So right, like we're getting around into passive house levels, passive house level there. But you can imagine the cost of adding all of those things, right? So like those are all like big jumps, and they'll probably require like an R43 wall is going to be 2x6 wall with like I think I put 3 inches, like it's 3 inches of exterior insulation on the outside, right? So then you need specialized screws to put it on the thing, and all of that kind of stuff. And then it's the point of diminishing returns, right? So you go from 49 gigajoules to 48 gigajoules, right? So like that is a huge amount of expense for minimum.
Darcy, when you put insulation on the outside of a frame wall, do you have to worry about thermal bridging, reducing the R value of the insulation? Because you've got, some people put Z-girts on, galvanized Z-girts.
Yeah.
And things like that, and they're just like bathtub plugs for energy going out of the buildings.
Yeah. Well, yeah. So then those are all that like I'm usually not dealing with houses that are getting that specific about it. Yeah. And like if you go through sort of the passive house, you would have to be much more on top of that kind of thing. The ones that I'm dealing with, it's usually smaller. It can be smaller amounts, whatever. Right. So the most I've dealt with is 2 inches of exterior insulation. But yeah, you want to be mindful of thermal bridging. Hot 2000 doesn't factor in thermal bridging as much, for sure.
I'm having a hard time understanding why the air changes decrease as you're going to the higher steps.
Because the air that's leaking out is taking with it energy. So any energy that escapes out of your house is heat that you're going to have to put back into the house. So as like drafty houses, cold air is sneaking in, and then whatever of your hot air is escaping, that's energy that you need to replace.
Is that number on the air changes your door fan test? Sorry.
Yeah. So those are all, that's the door fan test. So it would be 0.6 air changes per hour at 50 pascals. So it would be a pressurized house. So your natural, like it wouldn't be 0.6 air changes per hour when you're just sitting in your house. It would be a very small fraction of that. It would be even less. So there wouldn't be a lot of, and that's where, right, especially on days where the temperature inside the house and outside the house is the same, like you're not going to get any movement, and then you're going to start getting moisture problems and air quality problems and that kind of stuff. So then you want to, you need to compensate with mechanical ventilation.
Okay, so this is basically just saying how leaky the house is for the air. And are there separate standards that say how frequently you should change the air for health reasons, or that's not included?
Well, so there's a little bit of a role in it, but it's more like if you have 3 or 4 bedrooms, this is the number of liters per liters per minute that need to be going through the house. Yeah.
You have 2 people living now.
Yeah. But if you have and that's kind of why I don't like that solution of just putting in a bath fan, a continuous bath fan, because if you put an HRV, then you're going to be like, I can do the commissioning. I haven't done it, but I can do the commissioning where you, it's like there's this many people living in the house, so then the house needs this many liters per second that are going through it, and then you commission the HRV to deliver that amount, whatever, right? So then you deliver, and then you remove air from the places where you want to remove air, so bathrooms, kitchen, all that stuff, and then you supply air to bedrooms and stuff like that. Okay, that's the measure. So now BC box. So this is kind of going in the other direction. So perimeter of most of these measurements are going to be similar. So the perimeter of wall, 264 feet, same height, 9 inches, same area, 2,106 square feet. Surface area though is quite a bit lower, 4,614, because it's going to be 2 floors, right? So 2 floors. So same area, much lower surface area, volume 2,000 or 20,000 cubic feet, and surface area to volume at 0.23. So that's quite a bit better than This one, so 0.35. Step 3, no problem. Step 4, basically just throwing a heat pump on it. So it's already step 4 at, so this is just with double pane windows. Yeah, so just double pane windows, R22, just bringing the air changes per hour down to 1.5, and putting a heat pump on it, or making it all electric. So that's that natural gas being quite a bit cheaper, right? So yeah, so 1800, and then so step 5. Step 5, bring your air changes per hour down to 1. Walls, so adding some exterior insulation on the walls, R60 in the attic, and then leaving everything else the same. So then, yeah, so then, and then you're at step 5. So much easier to get to, than this one, right? So the R43, R80, and 0.6 air changes per hour. So, and this house, right, with all the corners and all that kind of stuff, is going to be a lot harder to get to 1.6 than this one. This one would be pretty easy to get to 1.6. Especially if you're working with a builder that's able to do 0.6 with a house like this. With this one, it'd be much easier. And I mean, this is sort of the extreme. You know, if you have an L-shaped house or a T-shaped house, right, like that's going to be much easier than something like this. Yeah, if you have a box, yeah. And for existing homes, it's the same kind of thing, right? So like if you, there's lots of existing homes, like the BC box, that are all over, that are quite easy to get very close to, like make very efficient with triple pane windows, exterior insulation. They're all box shaped. Find something that has lots of houses on, or lots of windows on the south side, and you're basically there. So this is my home, just for comparison. So this is my house. Air changes per hour at 3.8, a little bit bigger, so floor area 2,500. Walls are R12, attic is R60, triple pane windows, foundation R12. So it's a box with an addition, which if I was going to buy it again, I wouldn't. But I'm doing, and as an energy advisor, I would stay away from homes that have an addition. But the, and then here's sort of the costs. So my EnerGuide evaluation for my house comes to 88 gigajoules. That's with the heat pump and everything. Their estimate was 42 gigajoules of natural gas and 46 of hydro. My actual use was 30 gigajoules of natural gas and 54 of hydro. Their estimated annual operating cost was 2,400. My actual cost was 2,800. My EnerGuide rating, so like 30 plus 54 is 84. So like I'm a little bit below, but I use a more hydro than they would have estimated. But we have lots, like I have kids and we leave the lights on all the time. And we have a lizard that has a heat lamp and all of those kind of things, right? So it's, we use quite a bit more hydro. And then for the EnerGuide rating, they assume that you're heating your house to 22 degrees. So I don't heat my house to 22 degrees. I heat it to 20 degrees. And I've noticed a lot when I've tried to get homeowners who, and they're often engineers, how much, who track their expenses, and they have years of data or whatever about how much energy their house uses. And it can, sometimes it's quite close, other times it can be quite a ways off. So if someone has a wood stove that they're keen on using, or they use an extreme setback. So I had someone, at night their house went down to 14, something like that, right? So that's gonna change some things.
So do you have a central dual fuel system, or a furnace and a heat pump separate?
I have a dual fuel system. And then I push the heat pump to do as much as it can. So I have a 2-ton heat pump, but so this is my house. This is my
And
this
that's
is
part of why the cost is a little higher
Yes.
for your actual.
Yeah.
It's because you've got it set for the heat pump to work at colder outside temperatures.
Yeah. So I set mine at so I can set mine at, I think it's at minus 12 degrees Celsius. So you can see here your auxiliary heat. So this color here is my furnace, whatever. But you can see vast majority of the year, it's all heat pump. So that's cooling, then heat pump. So then that's natural gas.
The stage 2 heat, the second stage.
Yeah, so heat is your first stage of the heat pump, and then stage 2 heat is also heat pump. But it's the heat pump's putting out more or whatever.
It's not auxiliary resistance.
Nope.
Electric club.
No. So for this system, auxiliary heat's going to be this first stage of your furnace, and then stage 2 auxiliary heat would be the second stage of the furnace. And you can see like it very rarely goes into stage 2. Very rarely goes into stage 2, and stage 2 would be probably like someone left the door open or something when it was cold. Like very rarely would go into stage 2.
So can you define more what's meant by stage 2?
I'm kind of I know what it is for a furnace, and I'm assuming it's the same for a heat pump. But stage for a furnace, old furnaces, they all just pumped out whatever their max amount or whatever, right? So like an old furnace, you had 100,000 BTUs. When the furnace was on, it pumped out 100,000 BTUs, which led to a lot of short cycling, right? So like when it's spring, you don't need 100,000 BTUs, you need 10,000 BTUs. So the house would go down, furnace kicks on, instantly heats the house because it's putting out way too much heat, and then shuts off, shuts on. So now they created 2-stage furnaces. So the lower stage puts out something more reasonable, so 30,000 BTU. So I have a 60,000 BTU furnace. So stage 1 is 30,000 BTUs, which it uses to heat the house the vast majority of the time. And then when it's minus 30 and you need 60,000 BTUs, it'll kick on to the 60,000. When the furnace turns on, it pumps out 60,000 BTUs to make sure that the furnace. And I'm assuming that's the same sort of thing with a heat pump.
Does that mean there are 2 compressors in your heat pump?
I don't know.
I think there's a variable speed on them.
Oh,
They were 1 speed, and then there are 2 speeds, and now they're variable speed.
It's an inverter heat pump.
Yeah. So and on my app, it'll say it'll give me a percentage of the compression. So when it's full out, it'll say 100% compression, and then when it's not, it'll just say 50% compression.
And your outside fan, your condenser fan operates at different speeds too.
Probably.
Slows up in speed.
You're getting outside of my.
Sometimes it must squirrel a lot, other times it doesn't work.
Yeah. But the interesting thing is that my house, so I have a 2-ton heat pump. At minus 10, it only puts out 1 ton of heat, because as the temperature goes down, the heat pump loses a bit of its capacity, and it still heats my house it still does a pretty good job of heating my house at minus 10. And according to all my calculations, it shouldn't be able to. So yeah, it's pumping out more heat than you would expect. Or my house is better than than my calculations. For my house?
Yeah,
Yep.
for your house, yeah. And it, 2466 is your total, or 68 is your total floor area?
Yeah.
Yeah. So walls, main floor, and foundation are both R12, and then you've got triple pane windows. Okay, cool.
And it's a 2-story. 2-story with or well, basement and main floor is what it is. Yeah, basement and main floor with some exposed floor area. I'll kind of just cruise through. Okay, so all electric homes. Yeah, for price parity, you want to minimize heating load, so you want to get it as low as possible. Stay in BC Hydro Tier 1 if possible. And this is sort of like I think it makes more sense to spend more on solar, doing more solar rather than trying to make your walls, like make the building simpler and spend more on solar and battery rather than lots of sums of money on making your walls super, super thick. Don't connect to Fortis. So there is a connection fee to Fortis, right? So it comes out to be $150 a year. So if you can not connect to Fortis and keep all of those things, keep your heating load down, it can get pretty close to price parity. It was easier when we had the carbon tax. It was pretty close. Yeah. Yeah, industry has it. Yeah. But I mean, if you right now, I wouldn't like if I with clients that are out of town that are thinking about propane, I try and encourage them just to go all electric because propane is expensive and it doesn't save you that much money compared month to month, if any at all. Just going straight to heat pump means you don't have to worry about getting propane delivered. You don't have to worry about any of those things. And most people they want to, if they're living out there, they want wood heat as well anyway, right? So
Who cleaned the snow off those solar panels?
not me. This is all AI generated.
Oh.
Yeah. Well, those are all the like everybody loves roof mount. If you're trying to go off grid or any of those things, I think it's better to do ground mount and have them more vertical. Yeah.
If that's 55 degrees, more or less the latitude, snow's off.
Yep.
Snow slides off most of the time,
yep.
depending on conditions, of course. But
Yep. No, it's
that's not probably 55 degrees. But.
Yeah.
There's another problem. I bought a ton of solar panels, and the roof structure has.
I suppose
So because of the deck.
Yeah, I guess. Are they down now?
Minimize electric resistance heating. Obviously, that's one of the somewhat like sort of the tricky ways with EnerGuide evaluations is they don't include atypical energy expenditures. So hot tubs aren't included. Garage heating, right? So garage resistance heating, or if you had those stupid mats for melting snow, those are not included. But you'd want to stay away from.
Is the vapor behind the heat pump for real, or is that something AI did?
That's something that AI did.
Okay.
But you will see that every once in a while when it's doing its defrost cycle.
Okay.
Yeah. So when you're right, so as it's running, it'll freeze up, and then it has to do its defrost cycle, and then see a little bit of steam coming off of it. So yeah, these are my feedback questions that didn't work. So. Thank you. If you have any questions,
You mentioned about 2000 program, and well, first off, I'm surprised it's still the same program that we used in the R2000 program back in the 1980s.
Version 13 now.
Okay. Is it available to the public? Is it publicly available? The free download?
It is, but I know people run into problems running it. I remember when I was doing training, they got us to do the free one, and it can be finicky. Yeah, but yeah.
Okay, yeah, good.
I put some cards there if anybody wants to grab a card, and feel free to email me
Sure.
or if you have any questions.
The program that we use for the energy modeling.
Yeah.
That's approved by ASHRAE 140. Is there any list of all the programs, all the software that's approved by ASHRAE 140? I just discovered that the program I've been using for the last 25 years isn't approved by ASHRAE.
Oh. So there is, but so I think what I'm thinking of is Better Homes BC has a list of all of the people that they accept it from.
Okay.
So
Okay, I'll go and look at that list.
yeah, but so it'd be like
The
Tekka.
commercial energy software modeling always takes into account forced air in ductwork. And that means a lot of convection along the walls. That means additional heat loss and heat gain.
Mm.
Whereas the F280 software considers, everything is just sitting still, which is more realistic for a residence.
Yes. Yep.
I watched a presentation a few months ago, and they were talking about how many of these programs came up with different results. So they did a house which they knew the real results. They sent it out to everybody who was involved with their programs and had them run it through their programs and try to calibrate their programs, see it closer to the results. And the ones that got close enough, then I think got that approval that you're talking about.
There's an ASHRAE, the standard 140 is actually a method for evaluating how close the software is to, and it's actually a really good idea, because otherwise you're not comparing apples to apples.
Yep. Yeah. No, and it's an ongoing issue because by code, the code is it just needs to be bigger than that. So I'm always running into houses where the
nature of a residence is different from a commercial building.
Yeah.
And a commercial building needs a different kind of software to model it from a residence.
Yeah.
So it's interesting that they have actually got a list of approved programs.
Yeah.
I know we both modeled Doug's house and we had a discrepancy.
Oh, okay.
And that's the reason for it.
Yes.
That I used a commercial energy software modeling program, and it did exactly what it's supposed to do, which is to predict a higher heating load.
Mm-hmm.
But it also would have predicted a higher cooling load. I suspect the reason for that is that it's made by Carrier Software System. And they sell air conditioning.
Yeah. And then so I can just take 5 minutes to chat out or kind of go over any of the rebates and stuff that are available. So there's not as many as there were. Like we were in a much better position about a year ago. But check out Better Homes BC. Better Homes BC will have a listing of all of the ones. There's most of the focus now is on income qualified. There's the energy savings program, which has it'll describe all of the it has tier 1, tier 2, and the different income levels that people will qualify through. And there's also the ECAP program, which is another income qualified one. That one's everything. You can Google that, ECAP, like BC Hydro ECAP program. That's one where the program pays for everything, basically. Like someone comes in, they assess your house, and then if you qualify for a heat pump, you qualify for those kinds of things, they'll pay for the entire thing. But Better Homes BC will have the regular rebates. The most of it Yeah, Windows. So Windows, it's $100 right now. So $100. If you don't qualify for the income qualified ones, it's $100 per window, up to 20 windows. There is heat pump ones, but I believe they're for people to switch entirely. There is a dual fuel for, frustratingly enough, there's a dual fuel for propane, tank propane. So if you have a tank propane, they'll you can get yeah, I don't know. I don't know, but yeah, if you have tank propane, you can get a good chunk of change to get a new furnace and a heat pump added on. And then for what's the other natural gas? Not Fortis, but the Pacific. Like if you're connected to Pacific, yeah, if you're connected to PNG, yep. There's dual fuel rebates for that. But for everybody else, they want you to go all electric. Or if you have all electric resistance, so if you have baseboards, there's $4,000 to get a.
That's sort of discriminating against us Northerners, because we can't do it.
Yeah, I would agree. I don't know. I mean, my assumption is that Fortis spent all the money because a year ago Fortis had a very generous.
And they had a list of 11,000 pages of compatible heat pumps and furnaces that they would offer the subsidy.
Yeah. No, I mean, it was whatever it was. I don't want to bum everybody out, but it was.
Has the federal government weighed back in again in this
department? So my understanding is like they've put up more funds, the Canada Greener Homes funds, but they're giving it to the province. So then the province is disseminating it through their Better Homes BC program. So, and hence the focus on income qualified. If people can qualify, but I mean I think it's frustrating because there's no more dual fuel for this area, even for income qualified. So they're getting. They're getting people to switch to all electric, which all electric is great for people that are keen and know what they're getting into, but it's not, it can cause problems.
What happens when the provincial grid is overloaded? With all the electric vehicles and all the heat.
Yeah.
The electric vehicles will save the day.
That's right.
My answer is it's above my pay grade.
You have to have solar panels.
Yes.
Yep. There are some penetrations in home that pretty standard. So like a dryer vent.
Yep.
Right. Is that that's just venting? That's part of your your leakage.
Yep.
Yeah. So I would assume that if you've got a natural gas hot water tank, that's a 4H hole going straight up.
Yep.
And worse, if you've got open to atmosphere, cold air feeding furnace return.
Yep.
Even worse, right?
Or an air pot.
It's just more area that's leaking out. So
You have an ERV or an HRV, you're not going to have that.
I agree.
Cold air.
Yeah. The point is that's where you have a house that's got cold air return. For 10% makeup, as the old standard was, you would just block that off, insulate it, seal it, and put an HRD into place, and then you just because most high efficiency furnaces now get their air from outside anyway, so it's not point from the house, right? Where the old furnaces used to pull from the house.
We set a cover on ours, the ones in the house, I close it off. If we're both in there, then I'll open it a little bit. If we have guests, I'll open it a little.
Yeah.
It's non-scientific.
Once you and this is where the technology stuff, like if you go all electric, then you can start sort of blocking all of that stuff. Like you don't need that stuff.
Like a vent, so like I said, a dryer vent, your kitchen.
You can do
vents. You can't. Some of these things you just can't get rid of. You still have to have a hole in the wall, right? So
heat pump dryer.
Well, or electric, but it's still, you know, your vent fan on over your stove, that's still a hole in the wall.
Yeah.
You
So
can't get rid of
event.
that. There's some things you just can't get rid of. So
Yeah. And I mean not but that's true. And like I wouldn't, you know, range hood something that you shouldn't get rid of, right? You should always have a range hood. But in the houses that I've done, right? So like in the north, it's one of the things that you hear like I go to presentations and all that kind of stuff. There's builders complaining about like I can't get a house under 2 or I can't get a house under 3 or whatever. Up here in the north, like people are less tolerant of drafty houses, right? Like most BC, my house is. I've seen lots of BC boxes that get under 3, and they're just a house like that. So that'll have two bath fans. It'll have a range hood, and it'll have the dryer vent, whatever, right? And just people being a little bit careful, and it's a box, whatever, right? And like you get pretty good air changes per hour because you know we've been building houses in the north for a very long time, and people are not keen on leaks in their house. So but if you're going to all electric, right? If you do some of the things where you make the building simple, and if you're going all electric and you have an HRV, right, you're getting rid of those bath fans. You could do a heat pump dryer, so then you don't have that, and then you just have your vent sacks and the range hood and your ERV intake and exhaust.
Don't need a heat pump dryer. Use a one with the heat exchanger in it.
Yes. Yep.
Yes. We've been using it for 30 years.
Yeah. Yeah. Nope.
Yes.
Yeah. The ventless dryers, all that kind of stuff. But on the other hand, I bought a heat pump dryer, and I have a small family, and we do a lot of laundry, and it has been a bit of like my wife hates it because it's there's a better one, so I'm going to try and convince her to buy another one, but a better one. But yeah, it fills up with lint, so then it takes a longer time to remove the lint. I have to take the entire thing apart and vacuum out the. Yes, once I clean it, that's what I'm going to do. But it has a whole bunch of lint traps, and I was very careful about cleaning all the lint traps as much. But we do, a load of laundry a day. 700 loads of laundry a day. Later it's full of lint, and I'm unhappy. But
Darcy, sometimes I get these ads for Arctic heat pumps. Is that just a come on kind of thing, or will they actually work down to what they claim, like to minus, now I'm going by memory, minus 20?
So they do work to minus 20. Let's see if I can get that. I think I had it over here. Yeah, that's what it is. So
You're using more electricity than, natural gas would be more.
Yeah, natural gas would be more economical. So they will work, right? So this is a good heat pump. So at minus 25 Celsius, you're getting 2 units of electricity for every 1 unit of 2 units of heat per 1 unit of electricity. So and I was gonna bring like the what is it? The like how much energy they put out. So BTUs. So capacity, that's what it is. So with a heat pump, they'll put out for this one and sort of the best of the best, you'll probably get 2 units of heat per unit of electricity that's coming out.
But the total capacity has reduced.
Yes.
Your 2-ton heat pump is down to less than 1 ton.
Yeah. So that's where the sizing becomes really important. So like my 2-ton, when it's at minus 10, is only going to be putting out 1 ton. And then as it gets colder, your capacity is going to go down. And at some point, you want to just switch to resistance heating because you don't want to oversize your heat pump too much, right? So if your heat pump's only going to put out, and like you've got, and that's where it gets quite confusing, is that you'll have a heat pump that can put out, let's say, 4 tons or whatever, right? So that'd be 50,000. So 50,000 BTUs, but that's at 8 degrees. You don't need 50,000 BTUs at 8 degrees. You need 50,000 BTUs at the minus 33, which is the design temperature for Prince George. So that Arctic heat pump is going to only be putting out whatever 20,000 or half of what you're needing. So then you need to come up with some other heat. So it'll be resistance heat or your furnace or all of those kinds of things. And then if you were going to size it so that your heat pump put out 50,000 BTUs at minus 33, then you have this enormous or multiple systems, which causes problems when it's, right? So like if you have 100,000 BTU heat pump, when it's -2 and you only need 10,000, it's doing all of this stuff to work, like, whirling up to get going, and then it meets your energy demand and then shuts down and then goes on and then shuts down. So you don't, for heat pumps, you don't size them to the lowest temperature. You size it so that you're always going to be relying on resistance heat to make up the difference when it's
And just
yes.
Just for clarification, I think you're talking about what's referred to as cold climate heat pumps. Arctic heat pumps, I think, is a brand name, but there's a class of heat pumps that are designed to work in much colder weather.
Yep.
And they're the cold climate heat pumps.
Okay. Yeah.
You want to call it a wrap, or is there?
Unless there's any more rebates.
No.
Thank you.
No problem.
Yeah, thanks very much.